Good afternoon, all of you. I'm M. Santhosh from PSRJC, Pochampad, Girls. Today we discuss the chapter differentiation. Long questions are completed yesterday. So today we discuss the short answer questions and very short answer questions. Okay. Question number 1. Find the derivative of the function cos AX from the first principle. Okay. Given question is find the derivative of the function cos AX from the first principle. We know that the first principle formula, what is the formula? F dash x equal to limit h tends to 0, f of x plus h minus f of x by h. F dash x equal to limit h tends to 0, f of x plus h minus f of x by h. Okay. Let the given function, what is the given function? Cos ax. Let f of x equal to cos ax. Let f of x equal to cos ax using the first principle formula. F dash x equal to limit h tends to 0, f of ax plus f of x plus h minus f of x by h is the first principle formula. F of x equal to cos ax. Given function is cos ax. Let f of x equal to cos ax and f of x plus h value. So in the place of x, replace of x by x plus h. So cos a into, in the place of x, we write x plus h equal to cos of a into x ax plus a into h AH. F of x plus h equal to cos of ax plus AH. Now f dash x equal to limit h tends to 0, cos ax plus ah minus cos ax by h. Limit h tends to 0. What is the formula? Limit h tends to 0, f of x plus h. What is f of x plus h here? Cos of ax plus ah minus f of x. What is the f of x value? Cos ax minus cos ax by h. Since it is in the form of cos c minus cos d. Here is c value. What is c value? Ax plus ah and d value is ax. Okay. Cos c minus cos d formula minus 2 sine c plus d by 2 into sine c minus d by 2. Cos c minus cos d equal to minus 2 sine c plus d by 2 into sine c minus d by 2. Cos c minus cos d equal to
ఇది స్లైడ్స్ ఉన్నాయి కదా
f dash x equal to it is the after applying the formula cos c minus cos d equal to minus 2 sine c plus d by 2 into sine c minus d by 2. Here c equal to ax plus ah and d equal to ax. Now after applying the formula we get f dash x equal to limit h tends to 0 minus 2 into c plus d. What is c? Ax plus ah plus d value ax by 2 into sine c minus d. What is c? Ax plus ah minus ax by 2 whole by h. F dash x equal to here minus 2 into limit h tends to 0 1 by h into sine here ax plus ax is 2ax plus ah is as it is by 2 into sine here plus ax minus ax get cancelled. Remaining function is ah by 2. Okay. F dash x equal to minus 2 into 1 by h limit h tends to 0 sine 2ax plus ah by 2 And here, observe here, we know the properties of limits. Limit x tends to 0, f of x into g of x equal to limit x tends to 0, f of x, and limit x tends to 0, g of x. Okay, now applying the property of limits, here limit x tends to 0, f of x into g of x equal to limit x tends to 0, f of x, and limit x tends to 0, g of x. Now here limit h tends to 0 sin 2ax plus ah by 2 into, apply the limit for here, limit h tends to 0 sin ah by 2, f dash x equal to minus 2 limit h tends to 0 sin, now here split the fraction, here 2ax by 2 is 2 cancel, you get ax plus here ah by 2, by 2, and the limit h tends to 0 sin ah by 2 by, here h is there, so take this here sin ah by 2 by h as h tends to 0. You know that as h tends to 0, now multiply and divide with a by 2 on both sides. A by 2 into h tends to a by 2 into 0. A by 2 into 0 is 0. So as h tends to 0, that implies ah by 2 tends to also 0. Minus 2 into limit h tends to 0 sin ax plus ah by 2 into limit, here limit h tends to 0 is written as, that implies ah by 2 tends to also 0, right here ah by 2 tends to 0, and sin ah by 2 by, here ah by 2 into a by 2. So here since multiply and divide the second term by a by 2, here multiply and divide with a by 2, here h is there, so here multiply and divide with a by 2, a by 2 by a by 2, okay, a by 2 by a by 2, it is equal to minus 2 into limit h tends to 0 sin ax plus ah by 2 into limit ah by 2 tends to 0 sin ah by 2 by ah by 2 into a by 2. Okay. Limit ah by 2 tends to 0 sin ah by 2 by ah by 2 into a by 2. Into a by 2. Okay. Now minus 2 into sin ax plus, now after applying the limit minus 2 into sin ax plus, here h by 2 is there. So here apply the limit h tends to 0. Put h equal to 0. Here 0 by 2 into, okay, here limit ah by 2 tends to 0. Sin ah by 2 by ah by 2 is in the form of limit x tends to 0 sin x by x. It is the formula. Okay. Sin limit x tends to 0 sin x by x equal to 1. We know that the formula limit x tends to 0 sin x by x equal to 1. So in the term limit ah by 2 tends to 0 sin ah by 2 by ah by 2. So here x. In this term ah by 2 by ah by 2, so it is equal to 1, so into 1 into a by 2 is as this, here minus 2 into sin ax plus ax into a by 2, get a 2 get cancel, here minus 2 into a minus, okay, 2 get cancel, minus into a minus a sin ax. Therefore, f dash x equal to minus a sin ax. Therefore, d by dx of cos x equal to minus sin ax. D by dx of cos ax equal to minus sin ax. Next, problem number 2. Find the derivative of the function x sin x x sin x from the first principle. X sin x from the first principle. Let f of x equal to x sin x. Let f of x equal to x sin x from the first principle. We know that the first principle f dash x equal to limit h tends to 0 f of x plus h minus f of x by h. Take here f of x equal to x into sin x. Given that f of x equal to x into sin x and f of x plus h value. So in the place of x, we write x plus h. So in the place of x plus h into sine. In the place of x, we write x plus h. F of x plus h equal to x plus h into sine x plus h. Okay. Now f dash x equal to limit h tends to 0 f of x plus h value x plus h into sine x plus h minus f of x. F of x value is x sin x whole by h. F dash x equal to limit h tends to 0 here x into sine x plus h x sin x plus h plus h into sine x plus h sin x plus h here minus x sin x is as it is x sin x plus h. Now take x comes together, take this side here x sin x plus h as it is here minus x sin x right here minus x sin x plus h into x plus h by h. F dash x equal to limit h tends to 0. So take x common here, x into sin x plus h minus sin x plus h into sin x plus h whole by h. That implies f dash x equal to limit h tends to 0 x into take x common sin x plus h minus sin x by sin x plus h sin of x plus h by h. Now here split the fraction here. Limit h tends to 0 as it is. Split the fraction here. X sin x plus h minus sin x whole by h plus h sin x plus h by h. F dash x equal to limit h tends to 0 x into here observe this term sin of x plus h minus sin x. It is in the form of sin c minus sin d. Sin c minus sin d. What is sin c minus sin d formula? 2 cos c plus d by 2 into sin c minus d by 2. 2 cos c plus d by 2 into sin c minus d by 2. What is c value here? C is x plus h and d is x. C equal to x plus h and d equal to x. Now, after applying the formula, here 2 cos c plus d by 2. X is as it is. Here 2 into cos c plus d by 2. What is c? X plus h plus d. What is d? X. X plus h plus x by 2 into sin c minus d by 2. Sin c minus d. What is c? X plus h minus d. D is x. X plus h minus x by 2 whole by h plus limit h tends to 0. Here h get cancelled. Limit h tends to 0. Sin x plus h. Right? F dash x equal to limit h tends to 0. Here x into 2 cos x plus x 2x plus h by 2 into sin of x plus x minus x cancel. Here h by 2 whole by h plus limit h tends to 0 sin of x plus h. Where f dash x equal to limit h tends to 0, 2 into x is 2x cos 2x plus h by 2 into sin into limit h tends to 0 sin h by 2 by h. Okay, observe here we know the properties of limits. limit extends to 0, f of x into g of x equal to limit extends to 0, f of x, and the limit extends to 0, g of x. Now here 2x into limit extends to 0, 2x into cos 2x plus h by 2 into limit extends to 0, sin h by 2 by h. Okay, write h here plus limit extends to 0, sin x plus h is as it is. Next. F dash x equal to limit extends to 0, 2x cos here 2x plus h by 2. So split the fraction. 2x by 2 is 2 to cancel, get x plus here h by 2. Into limit h tends to 0, sin h by 2 by h is there. So here multiply and divide with 2. Okay, observe here multiply and divide with 2. So sin h by 2 by h by 2 into 2 plus sin, apply the limit here, sin of x plus h. So in the place of s, we put 0, sin of x plus 0. As h tends to 0, that implies h by 2 tends to 0. So h tends to 0. So multiply and divide it, multiply with 1 by 2 on both sides, multiply with 1 by 2 on both sides. H into 1 by 2, h by 2 tends to 0 into 1 by 2 is 0. So as h tends to 0, we get h by 2 tends to also 0. F dash x equal to 2x into limit h tends to 0 cos x plus h by 2 into limit here h tends to 0. We write h by 2 tends to also 0. Limit h by 2 tends to 0, sin h by 2 by h by 2. Here 1 by 2 right here. 1 by 2 is right here plus sin x plus sin x. F dash x equal to 2x limit h tends to 0 cos x plus 0 by 2. So, sorry, we are applying the limit. We are applying the limit. We are applied the limit. So there is no limit h tends to 0 here. Observe this. There is no limit h tends to 0. We are applying the limit here. 2x into cos x plus, apply the limit, h tends to 0, that is 0 by 2, or 0 by 2 into, observe this, you know that limit x tends to 0, sin x by x equal to 1. Limit x tends to 0, sin x by x equal to 1. Here limit h by 2, here h by 2, h by 2. So limit h by 2 tends to 0, sin h by 2 by h by 2. It is value is 1. This value is 1. So 1 into 1 by 2 plus sin x. F dash x equal to 2x cos x. Cos x plus 0 is x cos x into 1 by 2 plus sin x. Therefore, f dash x equal to x cos x plus sin x. X cos x plus sin x. Therefore, the derivation of x sin x is the differentiation of x sin x is x into cos x plus sin x. X into cos x plus sin x. Question number 3. Problem number 3. Find the derivative of the function tan 2x from the first principle. Find the derivative of the function tan 2x from the first principle. Very, very important question for 4 marks. The solution, let f of x equal to tan tx. Okay, let f of x equal to tan 2x. Given function is tan 2x. Let the given function is f of x equal to tan 2x. Now using first principle, f dash x equal to limit h tends to 0, limit h tends to 0, f of x plus h minus f of x by h. Limit h tends to 0, f of x plus h minus f of x by h. Here f of x equal to tan 2x. F of x equal to tan 2x and f of x plus h equal to, what is f of x plus h? In the place of x, we substitute, we write x plus h. Tan 2 into x plus h. Tan 2 into x plus h is equal to tan 2 into x 2x plus 2 into h 2h. Therefore, f of x plus h equal to tan of 2x plus 2h. Now, f dash x equal to, you know that the formula, the first principle, f dash x equal to limit h tends to 0, f of x plus h minus f of x by h. F dash x equal to limit h tends to 0. What is f of x plus h? Tan of 2x plus 2h minus f of x. What is f of x value? Tan 2x whole by h. F dash x equal to limit h tends to 0, 1 by h into, here tan x is written as sin x by cos x. Here tan 2x plus 2h is written as, okay, 1 by h, take here, take this side. Tan of 2x plus 2h equal to sin of 2x plus 2h by cos of 2x plus 2h minus tan 2x is written as sin 2x by cos 2x. F dash x equal to limit h tends to 0, 1 by h into, we take LCM here. What is the LCM? Cos 2x into cos 2x plus 2h. Cos 2x into cos 2x plus 2h. Here, cos 2x, sin 2x plus 2h into cos 2x minus cos 2x plus 2h into sin 2x. Okay. Observe the numerator, it is in the form of sin of a minus b. Here sin a cos b minus cos a sin b. A is 2x plus h, b is 2x. So observe this, sin a cos b minus cos a sin b. This is the formula for sin of a minus b. Sin of a minus b. A minus b. F dash x equal to limit h tends to 0, 1 by h of sin of a minus b. Okay, 2x plus 2h minus 2x. Sin a, 2x plus 2h minus b is 2x by cos 2x into cos 2x plus 2h. The denominator is as it is. It is a sin of a minus b. F dash x equal to limit h tends to 0, 1 by h into, here 2x minus 2x get cancelled, sin 2h by cos 2x into cos 2x plus 2h. F dash x equal to limit h tends to 0, here sin 2h by h. Sin 2h in the numerator, sin 2h is there, in the denominator h is there, right here. Limit h tends to 0, sin 2h by h into the property of, using the property of limits, limit x tends to 0, f of x into g of x equal to limit x tends to 0, f of x into limit x tends to 0, g of x. So here limit h tends to 0, sin 2h by h into limit h tends to 0, 1 by the denominator cos 2x into cos 2x plus 2h. That implies limit h tends to 0, sin 2h by h is there. So multiply and divide with 2. Multiply and divide with 2. So we get the limit h tends to 0, sin 2h by 2h into 2. Into, here limit h tends to 0, 1 by cos 2x into cos 2x plus 2h. Here there is no s term is there. So right, 1 by cos 2x into limit h tends to 0, 1 by cos of 2x plus 2h. As h tends to 0, 2h tends to also 0. Okay. As h tends to 0, multiply 2 on both sides. 2 into h, 2h, that implies 2 into 0 is 0. So as h tends to 0, it implies 2h tends to also 0. F dash x equal to limit, here h tends to 0, That implies 2h tends to also 0. So limit 2h tends to 0, sin 2h by 2h into 2 into 1 by cos 2x. Here apply the limit. Apply the limit. Okay. H tends to 0. That means substitute h equal to 0. Substitute h equal to 0. 1 by cos of 2x plus 2 into h. Here 2 into 0. Right? 2 into 0. Well, that implies f dash x equal to, observe this, it is in the form of, we know that limit x tends to 0, sin x by x equal to 1. So here 2h, 2h, 2h. So limit 2h tends to 0, sin 2h by 2h equal to 1. Here into 2 into 1 by cos 2x is as it is. And 1 by cos of 2x plus 2 into 0 is 2 into 0 is 0. So cos 2x right here. Here 1 into 2, we have 2. Cos 2x into cos 2x. Cos square 2x. 2 by cos square 2x. Okay, we know that 1 by cos x is secant x. 1 by cos x equal to secant x. So here 2 into 1 by cos square 2x. 1 by cos square 2x is written as secant square 2x. Secant square 2x. Therefore, f dash x equal to 2 into secant square 2x. Therefore, the differentiation of tan 2x equal to 2 into secant square 2x. Problem number 4. Problem number 4. If f of x equal to, log of secant x plus tan x, then find f dash x. If f of x equal to log of secant x plus tan x, then find the value of f dash x. Okay. Solution. Given function f of x equal to log of secant x plus tan x. F of x equal to log of secant x plus tan x. Differentiate with respect to x. Differentiate the given function with respect to x. The f of x derivation is f dash x. F of x derivation is f dash x, where differentiate log of secant x plus tan x. Right here, d by dx of log secant x plus tan x. Okay. F dash x equal to, here secant, we know that d by dx of log x, equal to 1 by x. Derivation of log x is 1 by x. Here secant x plus tan x. Consider here secant x plus tan x is treated as x. Suppose secant x plus tan x is treated as x. Log x derivation is 1 by x. So log of secant x plus tan x is 1 by secant x plus tan x. And derivate the remaining function. What is the remaining function? Secant x plus tan x. D by dx of log secant x plus tan x. It is in the form of log x. Log x. Secant x plus tan x is treated as x. So d by dx of log x is 1 by x. So in the place of x, we write secant x plus tan x. And again, derivative the function secant x plus tan x. That is d by dx of secant x plus tan x. That implies 1 by secant x plus tan x into here d by dx of secant x. D by dx of secant x formula, secant x into tan x plus d by dx of tan x. D by dx of tan x equal to secant square x. You know that the formulas. D by dx of secant x is secant x into tan x plus d by dx of tan x is secant square x. D by dx of secant x is secant x plus tan x, secant x into tan x plus d by dx of tan x is secant square x. secant x into tan x plus secant square x. Take secant x common here, the numerators. Take secant x is common. Secant x into, after we get secant x into tan x plus secant x. So secant square x is there, so secant x common. Secant x into tan x plus secant x. So by secant x plus tan x. Secant x plus tan x, secant x plus tan x get cancelled. Remaining the answer is secant x. Therefore, f dash x equal to secant x. If f of x equal to log of secant x plus tan x, the derivation is secant x. Okay? Is completed. Next problem number 5. If y equal to log of sine of log x. Observe the question. If y equal to log of sine of log x, then find the value of dy by dx. It is given y equal to log of sine of log x. Solution. Given y equal to log of sine of log x, differentiate with respect to x. We have to find the value of dy by dx. Y is given. Y derivation with respect to x is dy by dx. Okay. D by dx of log of sine of log x. D by dx of log of sine of log x. Okay. Log of here sine of log x. Sine of log x is treated as x. Sine of log x is treated as x. So log x derivation. Log x derivation is 1 by x. So log of sine of log x. Sine of log x is treated as x. So log x derivation 1 by x. In the place of x, we write sine of log x. Sine of log x. Log x derivation 1 by x. In the place of log x, in the place of x, write sine of log x. And into derivate the remaining function, sine of log x. Sine of log x. D by dx of sine of log x. That implies 1 by sine of log x. Here, observe here, sine of log x. Log x is treated as x. Suppose log x is treated as x, sine of x derivation. Sine of x derivation cos x. In place of x, we write log x. In place of x, we write log x. D by dx of sine log x is cos log x, and derivate the remaining function is log x. Derivate the function log x. 1 by sine of log x into cos of log x and log x derivation. Here d by dx of log x. Cos of log x by sine of log x into d by dx of log x is 1 by x. So right here 1 by x. Cos of log x by sine of log x is cot of log x. Cos of log x by sine of log x is cot of log x into 1 by x. So f dash x equal to 1 by x into cot of log x. So if y equal to log of sine of log x, then dy by dx equal to 1 by x into cot of log x. Problem number 6. Find the derivative of log x power tan x. Find the derivative of log x power tan x. Solution. Let y equal to log x power tan x. Log x power tan x. We can't derivative this function directly. Okay, here log x is one function and tan x is also another function. Here two functions are there, log x and tan x. So we can't derivative directly this function. So applying log on both sides using logarithmic differentiation, taking log on both sides, log y equal to, we get log y equal to log of log x power tan x, log x power tan x. Observe this, it is in the form of log a power m, log a power m, it is equal to m into log a, m into log a. M is tan x, a is log x, m into log a. What is m? Tan x into log of log x. Tan x into log of log x. Now differentiate with respect to x. Differentiate with respect to x on both sides. Here log y derivation, d by dx of log y equal to d by dx of log y equal to, here observe the second term tan x into log of log x. Here two terms are there, two functions are there. One is tan x and another one is log of log x. So we use UV rule. We use UV rule, that is d by dx of UV equal to d by dx of UV equal to u into d by dx of v, u into d by dx of v plus v into d by dx of u, d into d by dx of u. Okay. Apply the formula tan x into d by dx of v, d by dx of log x plus log of log x, v into d by dx of u. That is the log of log x into d by dx of u is tan x. U is tan x. Log y derivation. Log y derivation with respect to x is 1 by y, and y derivation with respect to x is dy by dx. It is equal to tan x into, here d by dx of log x. D by dx of log x. Suppose log x is treated as x, log x is treated as x, d by dx of log x is 1 by x, d by dx of log x is 1 by x. In place of x, we write log x. So 1 by log x into d by dx of, apply the derivative the remaining function, that is log x, d by dx of log x plus log of log x into d by dx of tan x is secant square x, d by dx of tan x is secant square x, where 1 by y take this side, dy by dx equal to y into tan x by log x into d by dx of log x is 1 by x plus log of log x into secant square, log of log x into secant square, dy by dx equal to, okay, what is y value? What is y? Y equal to log x power tan x. So right here log x power tan x into tan x by log x into 1 by x plus log of log x into secant square x. This is the final answer. The derivative of log x power tan x is log x power tan x into tan x by log x into 1 by x plus log of log x into secant square x. Okay. Try this for homework. If y equal to tan inverse root of 1 minus x by 1 plus x, then find dy by dx. Question number 2. Find the derivative of the function tan inverse of secant x plus tan x. Question number 3. If y equal to x into sin inverse x by root of 1 minus x square, then find the value of dy by dx. Very short answer questions. VSA course. Very short answer questions. Problem number 1. Find the derivative of f of x. Find the derivative of f of x equal to e power x with respect to the function g of x equal to root x. Okay. Find the derivative of f of x equal to e power x with respect to g of x that equal to root x. Okay, solution we have to compute. Okay, given it, find the derivative of f of x with respect to g of x. Derivative of f of x with respect to g of x. We have to find derivative of f of x with respect to g of x. That is, we have to compute df of x by dg of x. Df of x by dg of x, that equal to f dash x by g dash x value. Given f of x equal to e power x, differentiate with respect to x, f of x derivation f dash x, e power x derivation e power x. Okay, derivation of e power x equal to e power x. And given g of x equal to root x, g of x equal to root x, differentiate with respect to x, differentiate with respect to x, g of x derivation is g dash x, and root x derivation. Root x derivation is 1 by 2 root x. Okay, we know that the formula d by dx of x power n equal to n into x power n minus 1. Apply the formula here. Here root x is written as x power 1 by 2. X power 1 by 2. So d by dx of x power n equal to n into x power n minus 1. After applying the formula, we get root x derivation is 1 by 2 root x. D f of x by dg of x. F of x derivation with respect to g of x is d f of x value e power x, and g of x value dg of x is g dash x. G dash x equal to 1 by 2 root x. 1 by 2 root x. Here the answer is 2 root x into e power x. 2 root x into e power x. Next, problem number 2. Find the derivative of log of tan 5x. Log of tan 5x. Find the derivative of log of tan 5x. Solution, let y equal to log tan 5x, log of tan 5x, differentiate with respect to x, x derivation with respect to y derivation with respect to x. Here, y derivation with respect to x is dy by dx into d by dx of differentiation symbol with respect to x is d by dx. D by dx of log tan 5x. Log tan 5x. Okay, first of all, the log tan 5x. Tan 5x is treated as x. Suppose tan 5x is treated as x. Log x derivation is 1 by x. Right? In the place of x, we write tan 5x. Okay. Tan 5x is treated as x log tan 5x. That is log x derivation 1 by x. Okay, right? X in the place of x, we write tan 5x. So log tan 5x is 1 by tan 5x, and derivate the remaining function. Derivate the remaining function tan 5x. That is d by dx of tan 5x. 1 by tan 5x. Here d by dx of tan 5x. We know that d by dx of tan x is secant square x. But here d by dx of tan 5x is there. So in the place of 5x, okay, 5x is treated as x. D by dx of tan x is secant square. In the place of x, we write 5x, and derive the remaining function d by dx of 5x. D by dx of 5x. 1 by tan 5x into secant square 5x into d by dx of 5x. 5 is constant. 5 into d by dx of x is 1. 5 into 1 is 5. Here 1 by tan 5x is written as sin 5x by cos 5x. Sin 5x by cos 5x into secant square 5x is written as 1 by cos square 5x. Okay. So this here cos square 5x. Okay, cos square 5x. Here consider cos square 5x. 1 secant square 5x is written as 1 by cos square 5x into 5 as it is. That equal to 5 into here cos 5x cos square 5x. 1 cos 5x cancel. 5 into here 1 by sin 5x into cos 5x. Sin 5x and 1 cos 5x is there. So sin 5x into cos 5x. Next, multiply and divide with 2. Multiply and divide with 2. 5 into 2 by 2 sin 5x into cos 5x. That equal to 5 into 2 is 10. We know that sin 2 theta formula. 2 sin theta into cos theta. In place of theta, we have 5x is there. Okay, in place of theta, here 5x is there. So sin 2 into 5x. Sin 2 into 5x is equal to 10 by sin 2 into 5x is 10x. 10 by sin 10x. And it is written as 10 into 1 by sin 10x. 1 by sin x. 1 by sin x is equal to cosecant x. 1 by sin x is written as cosecant x. So 10 into 1 by sin 10x is cosecant 10x. Therefore, d by dx of log tan 5x equal to 10 cosecant 10x. 10 cosecant of 10x. Problem number 3. Problem number 3. Find the derivative of cos of log x plus e power x. Find the derivative of cos of log x plus e power x. Solution. Let y equal to, let the given function y equal to cos of log x plus e power x. Y equal to cos of log x plus e power x. Differentiating with respect to x. Differentiate with respect to x. Y derivation. My derivation with respect to x is dy by dx. A cos of log x plus e power x derivation. The derivation symbol with respect to x is d by dx of cos of log x plus e power x. Okay, that implies here cos the derivation of cos of log x plus e power x. Okay, suppose log x plus e power x as treat as x. Suppose log x plus e power x is treated as x, d by dx of cos x. D by dx of cos x is minus sin x. Minus sin, in the place of x, we write log x plus e power x. In the place of x, we write log x plus e power x and derive the remaining function. Derivate the remaining function log x plus e power x, that is d by dx of log x plus e power x. Log x plus e power x. dy by dx equal to minus sin of log x plus e power x into d by dx of log x is 1 by x plus d by dx of e power x is e power x. This is the final answer. If y equal to cos of log x plus e power x, then dy by dx equal to minus sin of log x plus e power x into 1 by x plus e power x. Problem number 4. Find the derivative of e power x plus sin x into cos x. Find the derivative of e power x plus sin x into cos x. Let y equal to e power x plus sin x into cos x. Let y equal to e power x plus sin x into cos x. Differentiate with respect to x. Differentiate with respect to x. By derivation with respect to x is dy by dx. By derivation with respect to x is dy by dx, and d by dx of e power x plus d by dx of sin x into cos x. D by dx of e power x plus d by dx of sin x into cos x. Okay, observe this. D by dx of e power x is e power x plus d by dx of sin x into cos x. D by dx of sin x into cos x. Okay, here two functions are there. That is, one is sin x and another one is cos x. So it is in the form of UV form. UV form. What is UV rule? D by dx of UV equal to u into d by dx of v plus v into d by dx of u. By the formula dy by dx equal to same dy by dx equal to d by dx of e power x is e power x. Applying UV rule, sin x into d by dx of cos x plus cos x into d by dx of sin x. D by dx of sin x. Dy by dx equal to e power x plus sin x into d by dx of cos x is minus sin x plus cos x into d by dx of sin x is cos x. So dy by dx equal to e power x sin x into minus sin square x plus cos x into cos x is cos square x. Dy by dx equal to e power x plus cos square x minus sin square x. Cos square x minus sin square x. Okay. We know that cos 2x formulas. Cos 2x equal to 2 cos square x minus 1 or 1 minus 2 sin square x or cos square x minus sin square x. Here cos 2x equal to cos square x minus sin square x. Therefore, dy by dx equal to e power x plus cos square x minus sin square is cos 2x. Therefore, it is the final answer. Okay, dy by dx equal to e power x plus cos 2x. Problem number 5. If f of x equal to sin of log x, if f of x equal to sin of log x, then find the value of f dash x. Then find the value of f dash x. Okay, what is the given function? Given function f of x equal to sin of log x. Sin of log x. Differentiate with respect to x. Differentiate the function with respect to x. We get f of x derivation. F of x derivation is f dash x and d by dx of sin of log x. D by dx of sin of log x. F dash x equal to, observe here, sin of log x. You know that d by dx of sin x is cos x. So your log x is theta as x. Log x is theta as x. D by dx of sin x is cos x. Okay, right? In the place of x, we write log x. In the place of x, we write log x. So d by dx of sin log x is cos log x, and derivate the remaining function log x. And derivate the remaining function log x, that is d by dx of log x. F dash x equal to cos of log x into d by dx of log x is 1 by x. So f dash x equal to cos of log x into 1 by x is 1 by x into cos of log x. If f of x equal to sin of log x, then f dash x equal to what? 1 by x into cos of log x. Problem number 6. important for 2 marks. If f of x equal to, if f of x equal to 1 plus x square plus x cube plus so on plus x power 100 up to x power 100. If f of x equal to 1 plus x square plus x cube plus so on up to x power 100, then find the value of f dash 1 and the value of f dash 1. Okay, first of all, we have to find f dash x. First of all, we have to find f dash x. Given f of x equal to 1 plus x square plus x cube plus up to x power 100. Differentiate with respect to x. Differentiate the function with respect to x. F of x relation is f dash x. That is equal to d by dx of 1 plus x square plus x cube plus up to x power 100. F dash x equal to d by dx of 1. Observe here, d by dx of 1, d by dx of constant is 0. Plus d by dx of x equal to 1. Okay, we know that the formula d by dx of x power n equal to n into x power n minus 1. n into x power n minus 1. Okay, d by dx of 1 is 0. d by dx of x is 1. d by dx of x square is 2x. d by dx of x cube is 3x square plus so on. Plus d by dx of x power 100. d by dx of x power 100. We know that the formula d by dx of x power n equal to n into x power n minus 1. Here n equal to what? 100. 100 into x power 100 minus 1. 100 minus 1 is 99. So 100 into x power 99. F dash x equal to 1 plus 2x plus 3x square plus so on plus 100 power 100 into x power 99. It is the value of f dash x. So we have to find the value of f dash 1. We have to find the value of f dash 1. Now put x equal to 1. Put x equal to 1. In the place of x, we substitute 1. So f dash 1 equal to. Observe here, not x here 1. So f dash 1. F dash 1 equal to 1 plus 2 into 1 plus 3 into 1 square plus dash up to plus 100 into 1 power 99. Here f dash 1, not x here, f dash 1 equal to 1 plus 2 into 1, 2 plus 3 into 1, 3 plus so on plus 100. Here f dash x equal to 1 plus 2 plus 3 plus so on up to 100. We know that the sum of natural numbers. We know that the sum of natural numbers. Sum of natural numbers. Sum of natural numbers equal to n into n plus 1 by 2. n into n plus 1 by 2. Sum of natural numbers formula n into n plus 1 by 2. Okay, what is the n value? 100. 1 plus 2 plus 3 plus so on up to 100. So n equal to 100. n equal to 100. So 100 into n plus 1 by 2. n into n plus 1 by 2. So 100 into 100 plus 1 by 2. 100 into 100 plus 1 by 2. Here 3 into 1, 3 into 50, 50 into 101. 50 into 101 is 5050. 5050. Therefore, f dash 1 equal to 5050. Do this. For homework, question number 1. If y equal to log of cos h2x, then find dy by dx. Okay, given. If y equal to log of cos h2x, then find dy by dx. Question number 2. If y equal to Sine inverse root x. If y equal to sine inverse root x, then find dy by dx. Next, question number 3, important for 2 marks. If y equal to cosecant inverse e power 2x plus 1, then find the value of dy by dx. Question number 4. Find the derivative of e power sine inverse x. Find the derivative of e power sine inverse x. Next, last question. Find the derivative of tan inverse root of 1 minus cos x by 1 plus cos x. Find the derivative of tan inverse root of 1 minus cos x by 1 plus cos x. This problem can be solved by using substitution method. Okay? We find the direct answer. The class is completed. Krishna sir. End.